Hey everyone, sorry I can't be in class today, but this video, since I can't be there to walk through some of these problems in person, I thought I'd put together a little video to go through some of the ones that might be a little bit tricky. And so hopefully this will help you to better get through the practice today. So we're going to start off going through number one. And what I want us to realize here is this is a problem where we're going to need to use our product rule. Now, I don't want you to get too tripped up by the 3 in front. When I look at this problem, I think of my first function as being 3 times the secant of x. That can go together. And then my second function is tangent of x. So I'm using the product rule along with those derivatives of trig functions that you learned a couple days ago now. So my derivative dy dx, product rule says I take the first function, so 3 times the secant of x, times the derivative of the second. The derivative of tangent is going to be secant squared of x. And then I'm going to add, and I'm going to do the reverse. Now I have my my second function, which is tangent of x, and then times the derivative of 3 secant of x. Now, derivative of secant is secant x tangent x, so my derivative is just going to be 3 times secant x tangent of x. So now this is the unsimplified version, right? But I'm going to go ahead and simplify it. If it were multiple choice, obviously it wouldn't look like this. So I have my 3. Here I have a secant of x times secant squared of x. So really I have 1 secant of x here and 2 here. So I can multiply those and I'm going to get secant cubed of x plus I have 3 times, now here I have 1 secant of x, and then tangent times a tangent is going to give me a tangent squared of x. And that's my derivative for number 1. Now, number 2, hopefully we're all recognizing by now that this is going to be the quotient rule. And again, we're going to be using those derivatives of trig functions that you learned. So let's see what this is going to look like. When we do quotient rule, we start with the denominator. So remember that low d high minus high d low over low squared. So low means I take my denominator, 1 minus cosine x. I'm going to multiply by the derivative of my numerator, which is going to be cosine of x, minus, take my numerator as it is, sine of x, times the derivative of my denominator. Now when I look here, the derivative of 1 is just going to be 0. Now I know the derivative of cosine x is the opposite of sine. So if I have negative cosine x, that's going to give me a derivative which is positive sine of x. That's a little tricky. You have to be careful with your signs there. And now I have all over the denominator squared. Now, I'm not too worried about simplifying here. Probably what I would do, I guess I would go ahead and distribute cosine x minus, we had a cosine squared of x. I'm going to have minus sine squared of x all over the quantity 1 minus cosine of x squared. Now, here's where I will show you something, because this comes up a lot of times on multiple choice, and I want us to recognize it. I know there's an identity, I'm going to go up here, which says cosine squared of x plus sine squared of x equals 1. And I notice I have both of those here, it's just that the signs are opposite. So what I'm going to do is I'm going to factor out a negative 1. Which means I have negative cosine of x plus cosine squared of x plus sine squared of x all over 1 minus cosine of x squared. Now, you're probably wondering why I did this. And to answer the question, this will not be on the test. You won't have to do it. But again, it comes up pretty frequently on the AP exam, so I want to give you a heads up. Now, when I look at this simplified expression, now I see that I have cosine squared of x plus sine squared of x, and I know that's just equal to 1. So now what I have is negative 1. In parentheses, if I rearrange this, I have 1 minus cosine x. And in my denominator, I have 1 minus cosine x. I have that quantity squared. Now, since these two factors are being multiplied, I can actually cancel this with one of my factors in the denominator, and this all simplifies to negative 1 over 1 minus cosine of x. Now, I wouldn't have expected you to see that at this point, but I did want to show you that. At this point, what I'm most concerned about is, did you get the quotient rule and do you have the correct derivatives? So here's where I want you to pause the video. I'm going to go on, but I want you to pause and I want you to work through 3 through 6 on this page. You can go ahead and check your answers in Classroom, and then when you're ready, you can resume the video. And I'm going to go through number 7 next. Okay, now number 7, here's where the question changes a little. We get into those higher order derivatives, because now this is asking me to find the first 4 derivatives for the following functions. So here we have cosine, and now I can tell that I've got a chain rule here, right? If I look at this, and maybe I'll color code it, I see that on the outside I have 3 times cosine, and I'm going to have, sorry, this is sliding on me. On the inside, I have my function 2x. And again, this is still equal to y. I haven't done any differentiating yet. So let's take a look. My first derivative is going to be y prime. And I know I need to differentiate this first. So if I have a constant times a function, that derivative is just going to be my constant times the derivative of cosine. Cosine is negative sine. The derivative, I should say, of cosine is negative sine. So this is going to give me negative 3 sine. My inside is going to stay the same for right now. And then I'm going to multiply by the derivative of the inside, or multiply by 2. So if I simplify this, now I have negative 6 times the sine, and I still have that inside function of 2x. So that was just our first derivative. So now we're going to go again. So y double prime. Now I'm taking the derivative of sine, which I know is cosine. So I have negative 6 times the cosine of 2x. And then I'm going to multiply by the derivative of the inside, which is my times 2. So I end up with negative 12 times the cosine of 2x. All right, now third derivative, y triple prime equals. Now here my derivative of cosine is negative sine. Since I have a negative here, that negative times a negative is going to give me a positive 12 times the sine. Again, I still have that inner function of 2x. And I'm going to multiply by 2 because that's the derivative of my inside function. So I get, let's see, 24 times the sine of 2x. So now we're almost done. I'm going to denote this by y to the 4th. So now my function is sine. I know the derivative of sine is cosine. So I have 24 times the cosine of 2x, and the derivative of my inside is 2. So for my answer, I end up with 48 times the cosine of 2x. And that's my fourth derivative. All right, at this point, sorry that's sliding on me, what I want you to do is work through numbers 8, 9, and 10. So for number 8, you want the first 4 derivatives. For 9 and 10, only the first 2 derivatives. Once you've done those, checked them in, and feel pretty comfortable, then I want you to take a break. And then we'll come back to a couple more problems. So again, go ahead, pause this video. I'm just going to put these all in one video. So pause it, work through 10, take a break, and then when you come back, we'll pick up with the next problem. All right, so the next one we're going to do is number 12. And so this one looks difficult because of the notation that it's using. So let's see what's going on here. We have if f of x equals x squared plus 2x, right? Then what it's saying is the derivative of f of ln x is equal to. So there's a lot of stuff going on here. So let's remember d dx just is asking us to take the derivative. Now we have to deal with this. So f of ln of x. Before I start trying to take any derivative, I'm going to figure out what this function is. So I'm going to look back at f, and wherever I had an x, I'm going to plug in a natural log of x. So now my function becomes natural log of x squared plus 2 times the natural log of x. That is this function f of ln of x. And now I'm just being asked to take the derivative of this function. So for my first term here, I'm going to take the derivative of these separately since they're being added. For my first term, I'm going to need chain rule. My outside is that function squared. So I'm going to start with 2. My inside's going to stay the same, times the natural log of x. And then I have to multiply by the derivative of the inside. Since my inside is natural log of x, I know the derivative of that is 1 over x, so I'm going to multiply by 1 over x. Now, for my second term, I just have 2 times the natural log of x, so I have 2 times the derivative of natural log of x, which is 1 over x. Now, obviously, this as is doesn't look like any of my choices, so we have to do a little simplifying. So this is equal to this, so let's see what we've got. I've got 2 times the natural log of x over x plus 2 over x. So it looks like 2 times the natural log of x plus 2 all over x. And if I'm lucky, it looks like A is going to be our answer. So the important part here was actually working out what this function is and then using our rules to figure out that derivative. All right, next one is 14. Let me slide down here, adjust the camera so you can see it. All right, so now my function is the natural log of x squared. So again, I'm noticing here that I'll need chain rule. And it's asking me to find the second derivative when x is equal to the square root of e. So the next thing I notice is that I want the second derivative. Now, I'm not going to do anything with this specific value until I have the second derivative. The very last thing I'm going to do is plug in my square root of e. So for right now, I just want to look at my function and work out the second derivative. So I just copied my function. So now for the first derivative, I'm going to use my power rule first. So my exponent comes down, my inside stays the same, and then I multiply by the derivative of the inside, which is 1 over x. So let's see, I've got 2 times the natural log of x over x. Now, this asked for the second derivative, so I have to go again. And now I'm going to end up using quotient rule here. So I start with the bottom, so x times the derivative of the top. Well, that would be 2 times 1 over x. 2 times the derivative of natural log, which is 1 over x, minus the top, 2 times the natural log of x, times the derivative of the bottom, which is just going to be 1, all over x squared. So let's see what we can simplify. My x and my 1 over x are going to cancel, so I'm just left with 2. So I'm going to cancel those, and I have 2 minus 2 times the natural log of x, all over x squared. Now that I have my second derivative, I can plug in my square root of e. So if I'd have, I'm going to jump up here, f double prime, instead of x, I'm going to substitute the square root of e. Sorry about that. So let's see, I'm going to substitute that everywhere I have an x. So I have 2 minus 2 times the natural log. Again, instead of x, I have square root of e all over the square root of e squared. So let's see what we can do with that. Now remember, square root of e is equal to e to the 1/2. So now I have 2 minus 2. Now the natural log of e, that's saying e to what power gives me e to the 1/2, so that's going to just be 1/2. On the bottom, square root of e squared is just e. 2 times 1/2 is 1, so 2 minus 1 is 1 over e, and choice A is going to be my answer. All right. At this point, I want you to finish, so no, go back and finish 11 and 13, and then on the next page, work through 17. And then when you're ready for that, actually I need to grab my calculator for number 18, so I'm going to end this video here and make another short one for number 18.